Okay, so let's talk about limits. So let's start just with some basic notation. So if you look over here on the right, this top one right here, the way you read this is you say the limit as x approaches 1 of x cubed. Again, that's the limit as x approaches 1 of x cubed. Now the one here in the middle, again, the same thing. It'd be the limit as x approaches 1 of x cubed, except this little plus sign that's right here. The plus sign denotes from the right. So the way you would read that is the limit as x approaches 1 from the right of x cubed. And then the bottom one, you would say the limit as x approaches 1 from the left of x cubed. So that's how you read those three different notations. Now, how do you actually apply that? What is a limit? What's going on here? So in short, a limit is just what is happening to the y values as the x values change. So as your x goes to something particular, what does the y value go to? That's what you're looking at. You change your x, what happens to your y? Your x goes to a certain number. What does your y do? Where does it go? Does it go to a certain number? Does it go up to infinity? What's happening to the y value as you change the x value? That's what you're looking at with limits. So let's start here with this middle one. Let's start with the limit as x approaches 1 from the right of x cubed. So I've denoted where x equals 1 is. So x equals 1 is denoted at where that pink dot is. And this red function that's plotted here is the function x cubed. So if we want to look at the limit as x approaches 1 from the right of this function, what you want to do is you want to start on the right side of the graph, and you want to move to the left until you reach x equals 1. So you want to move this direction, so we're going to start up here, because this is the right side of the graph we have, and we're going to move to the left until we get to x equals 1. And right here, we're going to stop, because right there we've reached x equals 1. So as the x value moves from the right over to the left, what happened to our y value? Our y value went to 1. So you can see at x equals 1, y is equal to 1. So as we move from the right to x equals 1, the y value goes to 1. So you would say that this right here is equal to 1. So now let's do the exact same thing. I'm going to do it in a different color. Let's do it in green this time. So let's do the exact same thing, but let's do this bottom one. Let's do the limit as x approaches 1 from the left of x cubed. So again, here we're going to look at what happens to the y value of x cubed as the x value goes to 1 from the left. So we're going to start on the left, that's over here, and we're going to continue to move to the right until we get to x equals 1. So again, if we do this along the graph, down here, this is the leftmost part of this function, and we're going to continue moving to the right until we get to x equals 1. So we're going to move, okay, now we've reached x equals 1, and what happened to the y value of x cubed? Well, as you move along this green value, which is moving the x value to 1 from the left, as you do that, the y value of x cubed goes to 1. So that tells you that the limit as x approaches 1 from the left of x cubed is also equal to 1. Now what that means, if both of these are the exact same, so if you move from the right and you get to the same value, and you move from the left and you get to the same value, then that means that the limit as x approaches 1 of x cubed, it means it exists. A limit cannot exist, and we'll talk about that in the next video. But if these two things are the same, it means the limit exists, and the limit is going to be the same as it is for each of these cases. That means here, let me get that thing. That means this right here is also going to equal 1. Because as you move towards x equals 1, which x equals 1 is just where this black line is. As you move towards x equals 1, from the right you go to 1. As you move towards x equals 1 from the left, you also go to the y equals 1. Right here. You're going there no matter where, no matter if you're coming from the right or the left, the function goes to the same place. It goes to y equals 1, which means that as the limit of x as x approaches 1 from the right of x cubed is equal to 1, the limit as x goes to 1 from the left of x cubed is also equal to 1. So that means the limit as x approaches 1 of x cubed is equal to 1. So fundamentally, a limit is just looking at what happens to the y value as you move the x value to a certain location. That's all a limit is fundamentally. That's all you're doing. And we'll do a lot more examples of this in the next video. We'll do a lot more calculations. So if this doesn't make complete sense, go ahead and move on to the next video, and we'll go over this a lot more. And we'll talk about limits not existing as well.